Hi, good evening, Professor. My name is Rohan, and my ID is right here. So this is my assignment one for this semester. So in the first step, we are importing the Keras dataset from the Fashion Mist. So here we're just getting the train images, train label, test images, test label to get the dimensions for the first question. So I've just run separately. So here the dimension of train images are 6028, which is like three-dimensional, you can say. And the second one is the train underscore labels. It's one dimensional 6000, and dimension for test images are 1028, it's three-dimensional. And the last one, dimension for test underscore labels, which is 1000, again one dimensional. So the next one we have, what is the length of train label and test labels. So here's the length. I've just used the len function for that. You can see 6000, 1000. Next one we have, please show some of the train and test labels. So just to show, I've just print with the train label. I've used the values 10, 10 and 1000. So just printing the values right here, very simple code. So next one, I'm just showing the digital contact of image index 5 in the training data set, which I'm using the index 5. So just gonna show you all the values for index 5 right here. And the next one, we are importing the matplot library as PLT. So I'm just plotting the image of the index 5 in the training data set. So here I can see the image after running the code. The next one is what is the label for index 5 in the train underscore label, and looking for up in the above list, and what does that mean. So just using the index 5, so to print the train underscore label, just gonna give me two dimensions, so it is a pullover, you can say. Yep. Next one, I'm just showing the digital contact of image index 500 using the print method. So here you can see. And the next question, so it was plotting the image of the index 500 in the testing data set. So I'm using the same code as before, the using previous questions. So I'm just putting 500 index and showing the value as plot.show. So here's the image for that. The next one, what is the index 5 for the, sorry, what is the label for the index 500 in the test label, and looking up in the above list, what does it mean. So I'm just printing test labels in the index of 500. It's showing me two, which I've done over here as well. That's a pullover again. And here I'm just importing TensorFlow from the Keras as well, and importing it to categorical values. So moving on to the next question. So we have question number 10. Please import models and layers from the Keras library. So I'm just importing the models and layers. I'm also importing the TensorFlow Keras from layers as well. So I'm defining a sequential model and calling it in my network here. So I'm calling the Keras model and importing it to sequential, dense activation, and flatten. And I'm calling it in my network here. You can see my network is equal to model.sequential, as it's been already run, so I'm not running it again. And moving on to the next question, reshaping the images from 28 by 28 to one columns with 784 neurons. So I'm using two methods. One of them is from the books, which is mentioned on the first one. So this is the book method, and the next one is from the video, which is using the flatten method. So it's using from matplot library from flatten. So just very simple code used from the video. So next question, it's also from the book using the two methods, but it's kind of different from the previous one that we use. It's dividing the image by 255. So just using the train images as is a type, and it's the value is taking is float 32 and dividing it by 255. So this is the method which was given in the book. The one from the video is the one we are importing the libraries from the TensorFlow, Keras, utils, normalize. So yeah, that's the one. So I'm adding a hidden layer that has 512 neurons using ReLU activation function. So in the next question, so here you can see 512 neurons, and the activation I'm using ReLU. Input shapes 784. The next one is adding one more, another hidden layer. You can say that as 128 neurons, same as the previous question, and using the ReLU activation. So I'm adding another hidden layer. You can see as dense, layers.dense, 128 is the neurons, and activation is really low. Moving on to the next one, we have add the last layer as a 10 neuron dense layer that uses the softmax as the activation function. Why we use softmax for the last layer? So the softmax is like basically used as an activation for like multi classification problems where like class membership is required on like more than like two class labels or so, and in here we have like more than two, as you can see. So that's why we are using like softmux as an activation function, and I'm using this code for like my network.add where like activation is like softmux. In the next one, we are setting like two different like yeah. So the next one, I'm using my network as compile, as here we have an atom optimizer. So here we just gonna see the accuracy and the loss curve in the next question. So I'm using importing the TensorFlow keras util to categorical from the library. So that was the setting number one, and the question number 17 part 2 is right here and the below. So I'm compiling the code right here, so just to make different from here. And the next one, after the compilation, please try to find the pattern using the fit command. So just using the fit command in the next one, as before we use the compile function and we just like fitting the values in the epochs 10 and batch size 128. So the epochs should be, as mentioned in the question, should be 10 as I've used here. So here you can see 1 to 10. So here the accuracy score is like constantly increasing as the loss score is constantly decreasing. So here we can see it's like clearly showing that the accuracy is greater than the loss score, and it's increasing as loss score is decreasing. Next one, we have how do you compare the fashion mist with what we learned in the class. So as loss score is like decreasing by the values coming on to the 10th, and the accuracy is like increasing. So as accuracy is like higher compared to the more as compared to the fashion mist data, which has like more complex handwritten codes. So yeah, that's the answer for that question. So use the evaluate, calculate the achieve accuracy and loss over the test images and label. And do we have overfitting or no? So using the print method to see the test accuracy, I've used the function my network, getting the both accuracy and loss score for the same for the test images and test label. So as you can see the test accuracy, I'm just gonna zoom in, it's 0.87, and the loss score is like very low, less than before, which was 0.24 something. So yeah, so we don't have the overfitting as the values are constantly increasing in the terms of accuracy and the loss is constantly decreasing. So that was the end of the assignment, professor. Thank you.